I'm going to do a few of these problems with you to help you go through the thought process. Lithium is simply Li, nitrogen is simply N, except for the fact that nitrogen is one of the diatomics. So there's 2 there, that's one of your 7 diatomics. Now, lithium nitride is an ionic compound. I know that because lithium is a metal, nitride is a non-metal. So I need to be able to crisscross that. So you need to be able to know your charges from the periodic table. So keep this periodic table handy, but over here is your lithium in the first column, 1 plus charge, and over here is the nitrogen, this light blue column with 3 minus charge. And so that's how I know what these charges are. Now I go back, and now I crisscross. So this superscript becomes the other subscript, and this superscript becomes the other subscript. Charges are not written, ones are not written. And that is lithium nitride. Later on we can come back and balance that. And now let's go on to the aluminum. Again, not one of the diatomics. Oxygen is one of your diatomics. Another ionic compound, so aluminum and oxygen. So aluminum is over here with a 3 plus. Oxygen is over here with a 2 minus. So 3 plus, 2 minus, and crisscross. Al2O3. Then again, you can go back and balance that a little bit later if you would like to do so. Sodium carbonate, Na2CO3 yields sodium oxide plus carbon dioxide. Again, this comes from crisscrossing. There's my sodium 1 plus. There's my carbonate 2 minus. And when you crisscross that, you get the sodium carbonate here. Same thing for sodium oxide, Na 1 plus, oxygen 2 minus. And then crisscross that. That 2 minus pops up here. Again, you don't write 2's and don't write 1's. This is covalent. You can see the Greek prefix. There's now we have a covalent, and so it's literally dioxide, 2 oxygens, and an implied monocarbon, so carbon just 1. That is that. Number 4, zinc is just zinc. Again, not a diatomic. Now we have a gold with a Roman numeral 3, so that's the charge. Gold falls within this D block here, where you don't know the charge just by looking at the periodic table. And so you need to be told the charge with Roman numeral. So gold, 3 plus, and then phosphate, one of our polyatomics, 3 minus. Crisscross, and then you can reduce the 3's, and you get simply AuPO4. Arrow. And now we end up with a zinc, 2 plus, phosphate, 3 minus. Crisscross, zinc, 3, PO4 with a 2. The 4 and the 2 comes with a 42 unless you put in parentheses. So those are zinc 2-phosphate. And then gold comes out by itself. Zinc has replaced the gold. Chlorine gas, that's one of your 7 diatomics. Lithium plus 1, iodide minus 1. Again, iodine is over here, minus 1 charge. Lithium still over here, first column. And so crisscross the 1's, lithium iodide. Lithium chloride, chloride's minus 1. Iodine is a diatomic, I2. And then you balance. Notice the 2 didn't come over with it. That 2 is there because chlorine's a diatomic. There's no 2 here because lithium is a plus 1 charge. The 2 appears here because iodine is a diatomic. There's no 2 here because lithium is a plus 1 charge. Sodium, hydroxide. Hydroxide's a minus 1 charge. Sodium, oxide, crisscross that. 1 plus, oxygen 2 minus, crisscross that 2. Briefly, I'll do the sodium 1 plus, hydroxide 1 minus. The 1's cancel out. Water is H2O. magnesium, not a diatomic, react with hydrochloric acid, HCl, one of the acids you have memorized. Magnesium chloride, so magnesium, second column, chloride is not. So here's magnesium with a 2 plus, chloride over here, 1 minus. Cl, 1 minus. Crisscross that, end up with NgCl2. And then the hydrogen gas. Hydrogen is one of the 7 diatomics. Iron 3 chloride, again, iron is in the D block, so you don't know the charge, or we're told via Roman numerals. Iron chloride 3. Iron 3 chloride. There's the 3, becomes the subscript there. Plus sodium hydroxide again to form iron 3 oxide. So there's the iron 3 plus, there's the hydroxide 1 minus, crisscross that to name it with FeOH with a 3 out here. Now that 3 is not just for hydrogen, but for all hydroxide. And so put parentheses around it so you know to distribute that 3 later. And then sodium chloride, NaCl, sodium plus 1, chlorine minus 1. When sodium is added to water, so here's sodium, here's water, sodium hydroxide and hydrogen gas will form. So sodium hydroxide, the 1 charges cross out, and then hydrogen gas is a diatomic. Zinc, placed with lead nitrates. So that would be Pb 2 plus N3 1 minus. There's the 2, crisscross that. Lead nitrates with a 2, and again, it's not 32 oxygen, it's 2 nitrates. So what's formed? Zinc, 2 nitrate, zinc with 2 nitrates, and then lead metal. More problems. Solid iron. Iron, not one of the 7 diatomics, plus solid sulfur. I'm going to put that down as S. Sometimes online you'll see that as S8, but for this context we're okay with just S. To form iron sulfide with the 3 there. So there's the iron, there's the sulfide. Show the work after the side, there's the 3 plus. Sulfide is a 2 minus. There's my 2 minus, and there's my sulfide. And so crisscross that to get a 2 here and a 3 here. Again, the S, sometimes it's here online with an 8. That's a bit more truthful than just the letter S, but for this context, for what we're doing, this is okay. Reaction of solid sodium metal. So here's sodium with chlorine gas, one of the diatomics, sodium chloride, NaCl. Ammonium, another one of the polyatomics, NH4, and then nitrates, ammonium nitrates. That comes from a pretty big crisscrossing that doesn't amount to much, but 1 plus, and 3, 1 minus, and the ones we cancel out. So there's my ammonium nitrate. And this decomposes into a diatomic nitrogen, a diatomic oxygen, and water. Liquid C5H12, that's known as pentane. So here's pentane, that was given to you. I give you the formula since you don't know the organic compounds yet. Oxygen is diatomic, they form carbon dioxide and water. Nickel 2 chloride, nickel 2 chloride, oxygen diatomic are produced from the decomposition. Well, we didn't put that in the right order, so let's try that again. Nickel perchlorate, ClO4 with just a -1 charge, and so when you crisscross that, the 2 appears there. And now we got to bring this over here since we didn't quite do that right. I read in sentence order. And there we go. Thank you. That's a little bit better in order. So nickel chloride decomposes to make nickel chloride and oxygen gas. Glucose, C6H12O6 decomposes into carbon and water. Carbon is now a diatomic. It is not listed as such. Silver 1 acetate. So here's the silver with a +1 charge. C2H3O2 reacts with aqueous magnesium chloride to form solid silver chloride and magnesium acetate, C2H3O2. Aqueous aluminum nitride. Aluminum iodide, so this would be an I with a 3. Reacts with chlorine gas, diatomic, to form aluminum chloride and aqueous iodine, which is a diatomic. Potassium metal, not a diatomic. Water, to produce potassium hydroxide and diatomic hydrogen. Fluorine gas, another diatomic, reacts with aluminum bromide with a 3 thanks to aluminum's charge to form aluminum fluoride thanks to aluminum's charge. That 3 pops up, and liquid bromine, one of the diatomics.